Okay, so we're here with Honor Statistics Period 2 again, and we're going over the example talking about the distance and the price of flights, I guess, in America. Okay, awesome. So if you are in class right now, listening, watching, you should have your pen or pencil out, making sure you're ready to write down. So I see as I look around, not everyone has completed all the questions. The expectation is you're going to complete them with me as we do it. All right, so I've already taken the measure of putting the values into a table, and I decided that the distance of a flight explains the price. So I chose for my x values to be the distance and my y values to be the price. So let's go ahead and do the axes here. What is our lowest or shortest distance? 327. 327, so 320. And then our longest distance? What was it? 2,150? Yes.
So, Guillermo explained to me that if you like scroll down on the table,
yeah,
on the left side there's a magnifying glass, and if you press it, it puts you like.
Where? So, come on over, Guillermo. Show me.
Scroll down all the way down.
Scroll all the way down. Go back to that.
On the table side.
On the table side, yeah.
Scroll down.
Oh, man.
There's a plus sign there, and click on that.
Genius! Guillermo, genius level. Oh, Guillermo Molina for the win. My goodness. Oh, when they take down my YouTube page, I'm going to be saying it was Guillermo's fault. But, man, that's awesome. Well done, Guillermo. Perfect. Okay, so we're done with that ever again. What up, Desmos? All right. Sick. Love it. Guillermo, you will always go. I will remember you forever. I'll be dying and be like, thanks, Guillermo. All right. Lifelong fan. All right, so we've already done that. Great. Let's make the linear model. All right, so we're going to type in y sub 1. Approximate. Now, what do you guys want to use for the order here? Do you want to use what you did with algebra or with statistics? Okay, so that means we're going to use b plus mx sub 1. All right? So here is our model. All right? Now, hopefully in number 1, you decided to write down your direction, form, strength. So I'm not going to write a sentence here, but you should have written there is a. And Daisy, what did you say?
It shows the linear and moderate between distances. Okay.
One more.
Positive.
Thank you. Awesome. So linear, moderate, and positive. Now, I'm making this very clear, guys. I'm not writing in a sentence or context. You must do that. So make sure you put it into context in a sentence. All right? Now, what is R? 0.694. Well, I'm going to just round. Now, if you were unsure, because I know there's some students that are like, oh, is it weak? Is it strong? Once I write down 0.694, I know that that is a moderate strength. Okay? Strong really need to be getting into the 0.8s, 0.85s. All right, and weak really probably below 0.4, 0.3. So 0.7 is pretty much right in the realm of moderate. Okay? All right. Now, for the equation, we decided we were going to do the stats way, which means we have to put our y value with a hat on it. So fair or price, whatever you want to put. So price hat equals, we're putting the y-intercept first. The y-intercept is b over here, which is 177.22. Fair and price are the same thing. Put that up here. Plus, and the slope is 0.08. And make sure that's times the distance. Are there any questions about the model? So if you wrote down price hat equals 0.08 times distance plus 177.22, you switch the order, that's fine. That's totally okay. I don't care. All right, doesn't matter.
So if it's the non-stats way, does it still get a hat?
Yes. Oh, so this right here, the price hat, is the same no matter what you choose. The only option you have is the right-hand side, what order you write it.
I thought the hat was on for the reciprocal.
No. The hat means predicted. The hat means, in residuals, it's y minus y hat, observed minus predicted. That's a residual. Okay, you're good. Yes, Carl.
0.08.
Oh, I just rounded. It's 0.078. I rounded to 0.08 because we're talking about money. We're talking about price is being predicted here. The slope. M. I rounded it. 0.08. You're not done? All good. All right, so now interpret the slope. So I wrote on the board here to my right, if everyone takes a look, and you can please feel free to write that down or take a photo, that's fine. Basically, that is without context. I wrote down for each additional unit of x, you expect the y value to increase or decrease by your slope. So our slope is positive, so we're expecting the price to go up with every additional mile. And specifically, we expect the price to go up by about 8 cents. So I expect the price to go up by 8 cents for each additional mile. Now, if you're like, oh, well, that's really not that much money, fine, then change it to 100 miles. All right, so every 100 miles, you expect the price to go up $8. Okay? If you'd rather change the ratio you use, I don't care. Don't have to do that. You're not. You're good, Kira. It's all good. It's all good. I'll speak slower. Now, for number 5, I wrote on next to, on that same board underneath the slope, how to interpret the y-intercept. So for a value in x, that's 0. So the x values here are distances. So we're saying for a 0-mile flight, so literally going nowhere, I expect the price to be $177.22. And I heard, I think it was Michelle. You said, what the heck? Like, that's, how are you going to charge me that much money for going nowhere? Well, why do airlines, I know this might seem like we're doing fake data here, because we are, this is not real data. But when you guys buy an airline ticket, included in that price is this $177. Obviously, it's not $177, but there's a fee that you're charged just to get on the plane. Right? Why do they have to charge you that money? Well, they got to pay for the plane. They got to pay for the gas. Maybe you got snacks on the plane and drinks. They got to pay for that. They got to pay for the salaries for the employees, like the pilots and the flight attendants. All right, all of that. Get a different airline. All of that is included in this number 177. No, United sucks. All right, let's go to number 6. Always Southwest, forever. All right, number 6. Number 6. Is it appropriate to use this model? You have to go back to your scatter plot, click on where it says residuals plot. You're going to click it, and if you're having a little trouble being confused by the fact that there's 2 scatter plots going on, you can always scroll up and click off your original Y. And that way you have just the scatter plot for the residuals. And when you look at that residuals plot, I'm hoping that everyone notices this is an example of no pattern. This is a cloud of dots. So when you write down your answer for number 6, you're going to say, yes, it's appropriate. And please, tomorrow on the quiz, tell me why. Tell me why. It's appropriate because the residuals plot shows no pattern. Yes, Leslie F. If you put no, you could still be right. I'm checking. Guys, I really like doing group work, but I'm worried that we can't. So just stay quiet. If you got a question, ask. I'm checking on this question. I'll come to you, Charlize. I'm checking on this question for linkage. If you say yes, I need you to also write because the residuals plot shows no pattern. If you say no, I better be reading because the residuals plot shows a pattern.
And do I tell what pattern?
If you would like to, but don't get that wrong.
Has to have a pattern for it to not.
If it has a pattern, it's not appropriate. If it doesn't have a pattern, it's appropriate. The model's appropriate. Charlize.
How would the pattern look like on the graph?
So I think I tried to do this yesterday, right? There are a couple types of patterns you might see. You might just see a parabolic one, right, where it's curved. You might see what we call the fan shape or a tornado. Somebody called it. Fan shape the other way.
But it has to be a pattern with the order scatter.
So there's kind of two things you're looking at. Let me put the original back on here. Do you see my green dots? My green dots are the original scatter plot. I want a pattern. I want a linear form. I want my green dots to be linear, and I want my blue dots, my residuals, to be a cloud. Nothing going on. Because remember, residuals is basically like, okay, here's my data. The computer makes a model. The residuals, it's what's left over after it makes a model. So if there's something going on that's left over, then my model is not appropriate. I shouldn't use it. Right? But in this case, the residuals plot shows nothing, so the model is appropriate. Feel free to use it. Any other questions about this? It's a difficult question.
I understand it now.
Okay, great. Thanks, Jarvis. It's all good. I'm not mad. We're all good. Thanks, Bianca. Okay, so number 7, the last one. This will be the most missed question tomorrow on the quiz. I'm telling you right now. Right now, guaranteed. Number 7, r squared is the most missed question. R squared is calculated for us. It is 40.482. But I always write r squared as a percentage. So 48.2% of the change in your price of a flight. You can use those words. In the price of the flight can be explained by the distance of the flight. And I think most of you would agree that if you fly somewhere that's farther away, you'd probably expect to pay more money. But I want everyone to see, everyone should see that number, 48.2%, is not even half. Remember yesterday with the Corollas, it was something, wasn't it in the 90s? I already forgot. In the 90s? Right? That's really high. 48.2% is not high. So this is where I would use my air quotes and say this is a bad model because it's not very high. It's appropriate, but maybe it's not useful. What other things are going to drive the price of a flight that's not related to how long the flight is? How big it is. Say it again. Ooh, the different types of seats. With Southwest, don't have to worry about that. The what do you mean about destination, Jarvis?
Because if you're going to a place where like everyone wants to go at that time, then the price will be higher. But if you're going to
Exactly. Supply and demand, right? If you're going to a place like Vegas, that's one of the most popular destinations to fly to, it's going to be more expensive. Also, Jarvis, you mentioned it without really mentioning it, the time or part of the year when you fly. Flying around the vacation or like holidays like Thanksgiving, Christmas, you're going to pay more money because everyone's trying to fly. We're just talking about one-way flights here. Sure, who cares? Right? I mean, I don't know. Anything else you're thinking of? Flying on Wednesday is actually the cheapest day. Flying on Wednesday is the cheapest day.
So if we were to just write this
You're done. Yeah, I'm going. Saul had a really good question here if you want to listen to Saul's question. Saul's just making sure he knows what to do tomorrow. Tomorrow, I'm done, right? I wrote my statement. I'm finished. I'm going a step further and thinking about this as like a real life scenario. What else is going on here? Because believe it or not, when you guys log on to book a flight, right, all you're doing is using the algorithm created by these airlines to price their flight. It's all done by computers. Everything. All right? Question?
the weather.
The weather. Absolutely. That would definitely affect it. All right. Thanks for listening.